Namaskar my dear friends. Let's talk about some of the advanced diode circuits. So we'll generally talk about Clipper circuits. So there are a lot of circuits that is related to diodes, and we'll see all these kind of different circuits based on diodes in 2-3 sessions. So we'll see clippers, clampers and all those different diode circuits. So let's open LTSpice. So this is the new window that has been released by Analog Devices. Now what we will do is we'll just open a new circuit. So this is how new circuit we open. We'll quickly make one diode circuit. So let's put a voltage source by pressing V. So V for voltage source we can press. We will take one ground and then we'll put one diode. So diode we can press D to get a diode. Press Ctrl R to rotate it. Okay, so whichever direction you want you can rotate. Let us take one resistor so that we can keep a resistor here as a load, and then press escape. We will get out from this particular mode. Now we will wire it up by pressing W. You can wire it up, so you can press W to get the wires. The wiring is now complete. Now next step of this particular circuit is we have to assign the values of each and every component in the circuit. That should be the first step. Okay, so let us decide voltage source as sine wave. So what do we do? Just right click on voltage source. So we will get this particular window to assign the voltage values. So we'll go to advanced and we can put sine wave, right? So in sine wave it is asking for DC offset. So we'll just keep DC offset as 0. We will not give any offset value. Let us keep amplitude as 3 volts. So 3 volt picked up, and 3 volt down it will be there, positive and negative 3 volt. Let us keep frequency as 1 kilohertz. Okay, and time delay, okay, let's decide it 0, like we don't give any time delay. So that's all. This is my sine wave that has been assigned. Let's keep resistance value as 1 kilo ohm. Okay, so as you can see we have kept resistance as 1 kilo ohm. If you want you can put a particular diode, or otherwise keep it as it is. There is no need to give any diode. Or if you really want to give a diode, then right click it. You will have a choice of pick new diode. Okay, and this is how you can select any of the diode. So if you want you can always select 1N4148. Okay, so this is 75 volt diode of 200 milliamperes of current. Okay, so if you want this will be assigned. If you do not want, you can keep it the by default diode that is also having a voltage drop of 0.65 volt. So 0.65 volt drop will be seen by default. Anyway, we have kept it a practical diode so that we will be having an understanding. Now let's run this particular circuit and we will see what is the output, what is the input. So to run this particular circuit, since our sine wave is of around 1 kilohertz signal, so it is 1 millisecond for one period. So let's run it for 5 milliseconds so that we can have at least 5 periods. Okay, and this is how our transient response is made. If you want to have a window of side by side, you can always press this one. Okay, so side by side it will be there, or up and down it will be there. Okay, so this is for up and down and this is for side by side that I have already taught you. Okay, now if you press here, then you will get a voltage probe. Then if you press here, this will also get a voltage probe. So we want to see input and we want to see output. So to get a name, like let's say this is showing you VN001 and this is showing you VN002. Okay, so as you can see VN001 is the input, which is green color, and that is sine wave of 3 plus 3 volt and minus 3 volt peak to peak. And as you can see, whenever the diode is not working, that is whenever their pulse is negative, that time diode is not working, and in that case my voltage is 0. Okay, so this is how it is showing a clipping voltage. Okay, so voltage is getting clipped off. Understood? So this is kind of below clipper, so below voltage are getting clipped off. Okay, it is well suited when you like put the net names here. So let us put a net name by pressing N. We are getting net name window here. So we'll just put V in. So V in we can press it here, and then we'll put V out here. So what we'll do is just right click and name it as V out. Okay. Press a space bar to get this particular circuit fit in the complete window. And now if you rerun it, you will get this as voltage probe as this V in, and this is going to be V out. Okay, if you want to have a separate window of this particular graph, then right click it and you can press add plot button above for P and add plot button below by pressing B. Okay, so I'll just put like a below button, and suppose V out I want to place in this window. So what I'll do is I'll go here, left click it and drag it. Okay, so I can drag it and keep it here in this window. Anywhere if you want you can keep it, and that particular trace will come here. Okay, so that's the main understanding you should have. From here you have to pick that by left clicking it and bring it here. Okay, if you again pick it and bring there, it will go in that window. If you click it and take in this window, so this is how it is coming up. So you can see the below voltage are clipped off. To make it very better view, what you can do is come to left side, you will see a scale, and I'll just put minus 3 volt to 3 volt, and let's say tick voltage is 1 volt. So you can see 1 volt tick is there. Okay, similar to that it will be much more better view if I keep it up to 3 volt, and let's keep it minus 3 volt, and then let's keep it 1 volt step size. So this is properly seen as clipping diode. Okay, so alright guys, this is one of the circuit that we have seen. So hope you have enjoyed this particular circuit. You can rerun it and see that. Now let's do another thing. This is upper clipper, now we'll make it lower clipper. So what do? We can change the direction of diode and we can see that response as well. So what we can do, I'll just do one thing. I'll take this diode out and reverse it. So let's move this diode by pressing M or by pressing this move mode. I can go here and select this diode and take out. Okay, and then press Ctrl R to move it and press place again. Okay, so you can save the previous circuit as save as, go to save as and save it with your circuit name and keep it at your like a desk. Now we will simulate this particular circuit and see what is the response. Okay, so let's rerun it. It is already there, so what I'll do is I'll just remove the response window or the waveform window and I'll rerun it. Okay, so my waveform window has come. Okay, now let us do one thing. What is my input voltage? So as you know, input voltage is still my sine wave, which is plus 3 volt and minus 3 volt. Okay, now what will be the output voltage? Whenever it is positive, then it will be clipped, because at positive time diode will not work. Okay, that's the understanding. So you can go here and press V out and it will show whenever my input signal is positive, it is clipped off, and whenever it is negative, it is downward. It is showing little down. Why? Because it is showing around 4 volt, because 0.6 volt drop is there. It is because of this practical diode which is having 0.6 volt drop. Okay, good. Let's do one more thing. I'll just keep it as saved as. So clipper 1, I'll just save it. Okay, so this is my clipper 1 circuit. Shall we do one thing? What we'll do is we'll just try to modify this particular circuit by placing one let us say some reference voltage here at this place. Okay, so that will be my third circuit. So what we can do is we can move this particular, or let's delete all these things. Okay, so let's delete all these things. Okay, now let us put one voltage source as a reference. So I can put a voltage source here, and then I can put again one more ground here, and then quickly connect this circuit. So this is going to be my circuit number 3. Okay, let's remove this so that you can understand very properly like what is the circuit. So what is happening here? We have a sine wave. I can move it a little down. You understand that by moving you are disconnecting the circuit. So instead of moving, what you can do is you can press stretch or press stretch mode S. Okay, so press S, so it will come in stretch mode, and you can move it without disconnecting the signals. Okay, let's do one thing. We are going to put a reference voltage at, let's say, 0.5 volt or 0.1 volt or 0.2 volt, whatever you want. Okay, so let us say I will put 1 volt. Okay, so this particular reference voltage will be 1 volt. If I want, I can put a reference line as well. So let's say I will put one node as Vref. So Vref is put. Understood? That's all done. So what will happen, it will have little bit reference, so till it reaches 2 volt it will be still forward biased. Understood? So this is the meaning, that's what I want to tell you. So let's run it for 5 millisecond again. So what is going to happen, I'll just keep it right side, it looks better. So what will happen, my sine wave will start from 0 to 3 it will go, right? So what will happen basically is up to 1.3 volt, like this will be forward biased and it will still give you the output. So let us say this is my input voltage and this is my reference voltage, which is 1 volt. Okay, if you want I can do one thing, go here +3 -3 and let's put 1 volt as tick. So you can see 1 volt is the tick voltage V reference. Okay, now let's do one thing, we can see what is the output voltage now across this particular resistor. Okay, so we can see the resistor voltage is going up to 1 volt and then it is going down. Understood? So this is the meaning of with reference clippers, and this is still like upper clipper because the diode direction was reversed. Okay, so this is my circuit number 3, which we have seen how to insert reference voltage and we can still run this particular clipper circuit. Let's take another circuit which we can do one thing is which we can reverse the diode and again rerun this particular circuit. So you can take a screenshot of this particular response, this particular simulation, and you can do another circuit. So what I'm going to make a change is, let's move this diode and reverse it. So if you see reverse, and then what will be the change that you will see, this red line will go up. Okay, and this particular reference voltage will actually shift down, right? So let's see what is happening. Actually till like from 0 to 1 volt there will not be any signal below. Okay, so that's the understanding. So let's remove everything. Okay, once we run it, what we are going to see, let's make it right side. So this is my input voltage. Okay, and let's make the tick voltage as 1 volt. It looks good to see 0 1 2 3. Now what is the thing that we want to see, what is my reference voltage? 1 volt. So 1 volt there will be a reference voltage. Okay, at 1 volt you can see there is a reference voltage. Now what will be the output? So what will happen, tell me, till it reaches 2 volt, sorry, till it reaches 1 volt it will be reversed biased, so it will not give you output at all till it reaches there. So my output will be above 1 volt. So you can see my output is going to be above 1 volt. From 0 to 1 there is no voltage at all. So this is how the clipper circuit is working. Why don't we do one thing, instead of sine wave we'll make this as a square wave. So to make this square wave as the input voltage as a square wave, we can take right click and go to here and make this change pulse type as like a square wave. So I have already told you like how to do those changes. So my initial voltage, let us say 0, or let's say initial voltage as -3. We'll go ahead with -3 +3. Okay, time delay will keep 0, time rise let us say we'll give 1 microsecond, time fall will give let's say 1 microsecond, on time let us say we'll give 1 millisecond, and period will give 2 milliseconds, so that 1 millisecond on, 1 millisecond off. Okay, that's all. So this is my input signal which is going to be a square wave. Let's remove this and run it again. Why I am removing? So that you have an idea of how I am going to plot one by one, otherwise automatically it will change and you will be wondering like what happened. Understood? So that's the meaning that we should have an understanding. So see, very beautifully this is showing -3 volt to +3 volt my input signal. Okay, so we have pressed here and we are seeing V input. Okay, now if you want, why don't we do one thing, let us make changes of this reference voltage as 2 volt. Okay, so it looks little bit better, it will go up to 2 volt. So let's rerun it. Now if we press here on voltage probe, we will see at 2 volt there is a V reference. Now what will happen, till 2 volt there will not be any signal. Okay, so it will be reversed biased, so my output will be above 2 volt. Okay, so the V out will appear above 2 volt. Understood? And this drop is there because of this particular drop across the diode, which is going to be around 0.6 volt or 0.55 volt, something based on this particular diode. So hope you have a very good idea about how to simulate a clipper circuit in LTSpice and what are the different things that we can always do.